Okay, we're going to go ahead and start the Unit 8 review here on sequences and series. We'll start with finding the first 5 terms of some sequences. So example A from question 1 on the review says we have a sub 1 equals 5, and a sub n is negative 2 times a sub n minus 1 plus 3. So what we notice first inside this equation is the term a sub n minus 1. A sub n minus 1 means previous term. So every time we see a base of n minus 1, we know that means we actually have to plug in a previous term right there. So to find the first 5 terms, we can start with the first term, a sub 1, and that one, there we go, a sub 1 is easy to find because they gave it to us. A sub 1 equals 5. We'll move on to find a sub 2, and in order to find a sub 2, I'm going to have to use this formula. I'm going to have to do negative 2 times the previous term plus 3. The previous term for the second term is the first term, so I'm going to have to plug in the first term, which is 5. Let's go ahead and solve that. Negative 2 times 5 is negative 10. If we add 3, we get negative 7 for an answer. So a sub 2 is negative 7. Let's go ahead and find a sub 3. We're going to have to do negative 2 times the previous term plus 3. And this time, the previous term is a sub 2, which was negative 7. So we'll plug that in there. Negative 2 times negative 7 is positive 14. If we add 3, we get 17. And we can see the pattern here as we move along. To find a sub 4, all we have to do is negative 2 times the previous term plus 3, and this time the previous term is the number 17. We multiply it by 2. By negative 2, we get negative 34, and we add 3 plus 3, we get negative 31. And last but not least, to find the fifth term, we're going to go ahead and do negative 2 times the previous term plus 3, where the previous term was negative 31. So if we multiply that by negative 2, we get positive 62 plus 3. Our last term is 65, and we found the first 5 terms. That is a recursive formula where we see that previous term. We only have to do this process of plugging in the term that came before when we see a sub n minus 1 in an equation. Our example B is similar, except it doesn't have a sub n minus 1 in it. It has n minus 1, but there's no ace of there, so it doesn't mean previous term, it just means whatever n is, I subtract 1 from it to do this problem. So this one's a little bit more straightforward to solve. This is an explicit formula. So to find a sub 1, all I have to do is plug in 1. 2 to the 1 minus 1 power, and then add 3. 2 to the 1 minus 1 is 2 to the 0. 2 to the 0 is just 1. So 1 plus 3, our first term is the number 4. To find the second term, we take our formula, 2 to the 2 minus 1 power, and we add 3, which is 2 to the first power plus 3, which is 2 plus 3, which is 5. So the second term is 5. To find the third term, I just plug in the number 3. So the explicit ones, that was ace of 2. Oops. There we go. And this is ace of 3. Explicit formula is very, very straightforward. That's what explicit means. It means I'm going to be very straightforward with what I'm looking for. So you don't have to beat around the bush and go find previous terms. We plug in exactly what we want. So 2 to the 3 minus 1 power plus 3, which is 2 squared plus 3, which is 4 plus 3. That gives us 7. To find the fourth term, a sub 4, 2 to the 4 minus 1 power plus 3, which is 2 to the third power plus 3, which is 8 plus 3, and we get the number 11. And last but not least, ace of 5, which is 2 to the 5 minus 1 power plus 3, which is 2 to the 4th plus 3, and 2 to the 4th is 16. And when we add 3, we get 19, and we're done. We have all the first 5 terms. All we had to do was plug in the numbers 1, 2, 3, 4, and 5. All right. So let's go ahead and move on to question 2. Question 2 is going to be asking us whether our sequence is arithmetic, geometric, or neither. If it's arithmetic, we have to find the d value. If it's geometric, we have to find the r value. Let's go ahead and take a look at this first sequence. Negative 7, negative 12, negative 17. The first thing we should check is to see if I can add or subtract to get from number to number. In this case, to get from negative 7 to negative 12, I can subtract 5, and I can subtract 5 again to get to negative 17. So it looks like this is a pattern, and the pattern is minus 5. So that means that our pattern is minus. That's going to go ahead and tell us that this is arithmetic. Remember, arithmetic is when our pattern is plus or minus. So arithmetic. And the pattern is the D value. So in this case, D is negative 5. Let's check example B. Example B is another sequence. I can go ahead and check to see if I can add or subtract to get between these numbers. To get from 14 to 10.5, I would have to subtract 13.5. But to get from 10.5 to 7.875, I can already tell that that's not going to work. And if I plug it in a calculator, it looks like I actually have to subtract 2.625. So that's not a pattern, which means this is automatically not arithmetic. Let's go ahead and try something else. Because subtraction doesn't work, let's try to see if there's anything that will multiply. And we have a method for that. Let's see if we can find an R value. An R value is going to be any term from my sequence divided by the term that came before. So I'm going to take the number 10.5 and I'm going to divide it by the one that came before, the number 14. So 10.5 divided by 14 in my calculator gives me 0.75, and that could very well be an R value if it repeats in my sequence. So let's try it again. If the same pattern is found, then it's my R value. So we'll do 7.875 divided by the term that came before, 10.5, and it turns out that is also 0.75. So this checks out, and this is geometric. And R, I should do it lowercase like usual, R equals 0.75 or 3/4, however you want to write it. Let's go ahead and take a look at the next sequence. This one's given to us in explicit form, and you'll notice this one and the next one, C and D, are both given to us in explicit form. And this is the first time in this review where we've really had to know our formulas. And the two formulas I'm going to ask you to memorize for the test are the explicit forms of an arithmetic. I'm going to write arith, and that form is a sub n equals dn plus a sub 0. And I'm going to ask you to remember the geometric. I'm going to write geo, and that one is a sub n equals a sub 1 times r to the n minus 1 power. So knowing these two equations is super important because it makes questions like these very, very simple to solve. For example, this formula right here, 3 times n minus 4, that matches this pattern right here, d times n plus or minus a number, exactly. So that means I automatically know this is arithmetic. Not only do I know that this is arithmetic, I actually automatically know what my d value is because it's right here in my equation. It's the number being multiplied by n, which means it's right here, it's the number 3. And we can tell just by looking. Same thing down here. We can see how these pieces fit exactly. 2 times a number to a power, number times a number to a power. They match exactly, with the geometric formula in explicit form. So this is automatically geometric, and I can tell just by the way that the formula is written, especially because it has an exponent with n in it. So that geometric formula, and I can find the R value just by looking at the formula. It's going to be the number that's in the parentheses. So R is negative 5. All right, we're going to go ahead and pick up with finding terms in indicated questions in the next video.